Hi guys, welcome back to Block My Minute channel. Today what I'm going to discuss about is what is blockchain and how it works. To understand more about this one, we need to understand about how hash functions works and how distributed ledgers works. So let's start with hash functions. So hash functions is an algorithm that converts whatever the input that we are putting into a string that contains a set of numbers and characters. So the length of the string will be different from the algorithm that you're using. So here I use the SHA-256 algorithm. So it will be convert whatever the input that you are providing into a 64 character string. So what is the beauty of the hash is, as you can see, the I mentioned as a block by million here, and it will convert to a hash value. But if we change that m as the symbol m, then it will be totally create a new value as well. So even if you are removing a small space, that means it will totally create a new hash for that one. So the hash is not only for strings, but if you're using as a documents also, you can get a hash value for that one as well. But whatever the amount of the input that you're providing, you will be converted as a 64 character hash. But what's the beauty of the hash is you can't convert back. That means if you're providing a hash, you can't get the actual data. So let's move to centralized ledger. So centralized ledger, it's as you can see that I take it as a bank example. So there are four branches of the same bank, and then they're using the same ledger. So what will happen here was whichever the bank is updating the things, that will be updated to the central ledger, and it will becomes back as the next rows, and next rows will be updated by each of the branches. And then in the end of the day, they'll have one ledger that contain the information about the whole branches. But if the central ledger is gone, or if it's not there, then it means the all four branches can't do any stuffs by independently. So let's move to the distributed ledger. So distributed ledger is shown as this one. So each and every bank will be connected to each and every other ones, and they'll be maintain their own ledgers. So what they'll be do is they'll be update their own ledgers, and that updates will be go and happen to the others ledgers as well. So what is the difference between the distributed ledger and the blockchain is distributed ledger, it's not maintaining a structure like a blocks. So what will happen in the blockchain was we'll be maintaining a structure like a blocks, but and then we'll be connect those blocks as a chain. But here there's no blocks maintained in the distributed ledger, as well as there's no chain maintained here. But each and every blockchain is a distributed ledger, but not all the distributed ledgers are blockchains. So let's move how blockchain works. So as I mentioned previously, blockchain is basically a set of blocks that connected using a chain. So if there's a new block comes, it will be straight away goes and added in the end of the chain, and it will be maintaining a chain as well. So if there's another block comes, it will becomes and added to the end of the chain. So it's if we can simply relate as the blockchain as the one ledger, where that ledger has a set of transactions. We can say the transaction has each blocks, and if there's a new transaction comes, that will be going to the end of the row of the ledger, same as it will be go and join with the last block. So we'll see how the chain is building here. So first we'll be take as a single block, and we'll take two attributes of that block as hash and previous hash. So there are so many attributes stored inside the block, and I'll be do a separate video for that one. So for now I'm taking only two attributes, at hash and the previous hash. Hash is it's more like a fingerprint of that block, and the previous hash is the previous block's fingerprint. Block will be identified in the blockchain world as using their fingerprints as the hashes. So if there's a new block comes after the mining and stuff, it will be have the same attributes as hash and the previous hash, and the hash will be the new fingerprint of that block, and then the previous hash will be the previous block's fingerprint. And then based on this scenario, they will be maintained the chain by referencing the previous blocks. And then once it was approved, then it will be added to the chain. And for scenario there's another block comes, then that will also have the hash and the previous hash, and they will be maintain the link, and it will be added to their blockchain. But what will happen is if someone tampered one of these blocks in the middle, as I see it's previously as a OH and it's now moved to OV, then they need to update the next block as well, because that previous hash is different than the current block's previous hash. So then they'll be lose the link. So this is why it's very difficult to tamper the chain in blockchain, because if you tamper one block or tamper the data inside the block, that will totally change the fingerprint of the block, and that fingerprint is always referenced by the next block. So they need to update that block as well. So if they update that block, then that block's fingerprint will be changed, and they need to update the next one, so on. So it's very difficult, and it will be so time consuming as well, because each of these blocks and the hash of the blocks will be fingerprint of those blocks will be created based on the mining process called, mostly for if you take as a Bitcoin, it's called proof of work. So what they'll be do is they'll be process so much of computation power, put it inside that one, so it will be take at least 5 to 10 minutes to find the fingerprint for that block. So once they find that one, they need to do the same amount of work for the next block and next block, and for example if there's around 1000 blocks, they need to update all those 1000 blocks, and then they need to do the same thing for the next guy's machines as well. Unless if there's only one machine is updated, then the chain will be, as we shown, it's distributed. So once if one guy's machine is updated and if the next guy's machine is not updated, then you can't do any stuff with your own chain. It's more like you need to keep the same state as the others machines as well. So the next one is a Merkle tree. So as we can show in the previous scenario where each and every block contains a single transaction, but actually what will happen was this will be not as a single transaction. So for a time being there will be so much transaction will come into the blockchain. So to handle this issue, what blockchain is doing was mostly in bitcoins and ethereums, they're using as a Merkle tree. So they'll be get all the transactions and then they'll be processed to a hashing algorithm, and they get each hashes, and then they'll be append two hashes as a string, and then they convert that as a hash and create a new hash, and then they'll be get those two hashes and find the root hash. So this process will continue until they find the root hash, and this root hash only will be go and store inside the block. So once they store the root hash inside the block, that will be create the fingerprint of that will be go to as a one input for the fingerprint making, and then they'll be make the fingerprint of that hash using that hash, and they'll make a fingerprint for that block, and then they'll be at that block as referring the previous block as well. So why they need actually the Merkle tree was two things. One is it's very difficult to share all the transactions to each and every nodes, because it will be time consuming and it will be a huge process as well. So what they do was they'll be do this Merkle tree and they'll share only the root hashes. So when the miners need to do the validations and verifications, they'll come and get the whole Merkle tree and do their validations. Now the important stuff was using Merkle tree is to reduce the tampering of the transaction. As we can see in the previous one, how blockchain reducing the tampering of the chain. Here it's tampering of the transactions. So once if someone want to tamper this transaction as a transaction 4, then they need to tamper the hash of that one, and then that need to be changed as the top hash, and then they need to change the root hash as well. So this is a so long process. As you can see, it's only 4 transactions here, but actual process it comes 100 to 1000 transactions, so even more than that as well sometimes. So they need to do all those they need to do all those 1000 transactions comes as a tree. So then they need to append, and they need to change each and every hashes in the whole tree until the root hash reached, and they need to update this one, and then they need to go and change the root hash of the block, and they need to update each and every blocks as well. So this is a long process and it will take so much time. So the next one we'll see how the block distribution happens. So this is the another advantage of the blockchain, where each and every block will be sent to each and every nodes, and they'll be maintained the same state as well. So for a scenario, it's only having the 2 blocks at the moment, and account C wants to transfer some money to account D. So for that we need miners. So account A and account B, for a scenario example, it's acting as a miners, and they'll be do the mining process. And for this scenario, the account A is a luckier one, so he found the block. So once he found the block, he'll be added to that one as his chain, and then he'll be sent to each and every nodes in the system. And each and every node will be do the verification part by their own, and then they'll be added that to their state of the chain. So once it was added, then each and every chain at the moment, it's similar like all the other chains in the network. And for this scenario, account A will get some incentives for his computation power he used to find that block. So thank you guys for watching, and I will do more videos about blockchain in the future as well. So please shoot out your questions in the comment sections, and if you like the video, please like it, and please subscribe for more videos, as I am doing at least 2 or 3 videos per week. Thank you.